Hello, welcome to today's class. We are having this simple challenge here, but most students find this difficult because of the presence of these I present here. But here, if you are not familiar with the mathematics that has to do with imaginary numbers, you cannot actually evaluate this. Okay, so here we're going to give a breakdown on how to evaluate this without the use of the calculator. Okay, so we take our solution. Yeah. But before we go into today's solving, if you are new here, this is Math Prowess, and if you've not subscribed, subscribe to our channel. Here we roll out videos all the time. Okay, now the first thing we're going to look at here is this. If you look at the quantity here and that here, you discover that this is a conjugate of this here. Okay, but can we actually rationalize this denominator or raise the answer to this to give us a particular answer? I think that will not work out here, and so we're going to apply a simple rule, okay, equation, which is a special equation. We're going to apply the Euler equation. So if we apply Euler equation or formula to this expression here, so we're going to have our 1 plus the I root 3 will give us here 2 times e to the power of our I, the times pi all over 3. Okay, now if you want me to make a video on actually how we have these from this simplification, apply the Euler identity or Euler equation, then drop it in the comment section and I will not hesitate to make a video on that. Okay, so on the other side or the other hand, if we simplify the denominator, which is this, we're going to have our 1, then minus I root our 3. This is equals to our 2 times our e all raised to the power of minus I pi all over 3, right? Good. So we can go ahead to substitute these two values into what we have in here. And so we have our 1, the plus our I root 3 all over our 1 minus I root 3, everything here raised to the power of 10 will in turn give us our 2 times e all raised to the power of our pi all over 3 all over our 2 times our e raised to the power of minus I pi all over 3 all raised to the power of our 10. Good. Then from here, what we observe, we discover that this and this will leave the system and they have the same base number, right? So we're going to apply the property of indices, which says that when you have your a to the power of your m all over a to the power of your n, this is equal to your a to the power of your m minus n. So if we apply this property, then we can rewrite everything we have in here. So this is going to in turn give us our e all raised to the power of our I pi all over 3, then minus bracket minus our I pi all over 3 close bracket, right? Everything raised to the power of R10. So from here, this times this, which is minus times minus, that will give us plus. We know that, right? So this will end up giving us e to the power of our I pi all over 3, then plus our I pi all over 3. Right. This is easy, right? Good. So everything further raised to the power of our 10 here. So if we add up these, because this and this are the same, and so we're going to end up having our e all raised to the power of our 2I pi all over 3 all raised to the power of 10. This is pretty easy. Again, if we simplify this down, we can use this to multiply this, and that will give us something good. Applying the log, which says that your a to the power of your m n, this is same thing as your a to the power of your m, the bracket your n, right? So if we use this to multiply this is going to give us our e to the power of our 20, the I pi all over 3, okay? All in bracket. Okay, so with what we have in here now, then we can simplify this down. applying the Euler equation again, which says that if you have your e to the power of I theta, this is equal to the cos of your theta, which is cos theta, plus your I, the sine your theta. So from here, we're going to have our equation here, which is our e to the power of our 20, the I pi all over 3. This is equal to our cos your 20, let's put it in bracket, 20 pi all over 3 close bracket, there plus our I sine bracket open 20 pi all over 3 close bracket. Now, if we impute this or you simplify this is going to give you minus 1 all over 2, and this is going to give us root 3 all over 2 iota, or I, right? Good. So this will in turn give us our minus 1 all over 2, the plus the square root of 3 all over 2 I, right? I here, okay? So we can either put the I here or we put it here. It stays the same thing. Okay, so therefore, we cannot say, therefore, our expression, which is bracket open 1 plus our I root 3 bracket close all over our 1 minus our I root 3 all raised to the power of 10 here is equal to our minus 1 all over 2, then plus our I, the root 3 all over our 2. So this is the answer to this expression. So this brings us to the end. If you have a question to this procedure apply in evaluating this challenge, drop it in the comment section. We're going to meet you up there. If you've not subscribed, please subscribe to our channel. We love you. Bye.